In this video, we will compare supercritical fluid chromatography with HPLC, focusing specifically on the differences in system design, column choice, and real separation behavior. Chromatographers often ask one key question: what truly changes when you switch from HPLC to SFC? What makes supercritical carbon dioxide different? To understand why SFC behaves differently from HPLC, you only need one key idea. Supercritical carbon dioxide behaves like a liquid and a gas at the same time. It has low viscosity, moves through columns extremely fast. High diffusivity helps analytes spread and reorganize quickly. Good solvating power when mixed with modifiers. This combination is what gives SFC speed and resolution advantage, especially for non-polar to moderately polar compounds. Beyond the theory and definitions, the real differences appear in the system design, the choice of columns, and the way analytes interact with the stationary phase. Let's walk through these differences clearly. The first difference begins with the hardware system configuration. SFC uses supercritical carbon dioxide. A basic system consists of a carbon dioxide cylinder, a specialized CO2 pump designed for compressible fluids, a modifier pump for adding methanol or other solvent, and a back-pressure regulator which maintains carbon dioxide in a supercritical state throughout the analysis. In contrast, HPLC uses liquid solvents only. Its system basically consists of solvent delivery pumps, an auto-sampler, a column oven, and a detector. While HPLC pumps solvent against the resistance of the column, SFC requires the entire system to be pressurized. We use a specialized back-pressure regulator to maintain conditions typically between 100 and 400 bar, ensuring the carbon dioxide remains in its supercritical state. Next, we see a critical divergence in the choice of columns. HPLC typically utilizes a wide range of column chemistries to address various separation challenges, with reverse phase being the industry standard. SFC, however, employs columns with specific stationary phases tailored for the unique polarity of the supercritical fluid. Crucially, SFC columns often feature smaller particles. To meet the unique demands of supercritical fluid chromatography, Shimadzu introduces the Shim-pack UC series. Unlike limited traditional options, this series offers 20 distinct stationary phases, giving you the precise selectivity needed for everything from basic to acidic compounds. In high-pressure liquid chromatography, the interaction is liquid-solid. The separation is driven by polarity and hydrophobicity, where analytes partition between the liquid mobile phase and the solid stationary phase. In superfluid chromatography, the interaction is fluid-solid. This interaction is described as a complex interaction with carbon dioxide and modifier. The unique properties of the supercritical fluid and the added modifier create a more complex separation mechanism than in HPLC. SFC is particularly suitable for neutral or non-polar compounds, but with the right stationary phase and modifier solvent, it can also retain acidic, basic, and moderately polar molecules. The retention time chart shows how the same three analytes behave differently across 20 different stationary phases. When optimizing HPLC, switching modes means completely flushing your system to switch from water-based solvents to non-polar solvents like hexane. When optimizing the mobile phase and stationary phase for SFC, normal phase columns can be replaced with a reversed phase column without changing the type or composition of mobile phase or modifier. This highlights a major strength of SFC: rapid column screening and speedy method optimization. It is ideal for compound libraries, natural extracts, or unknown mixtures.
Excellence in science. Shimadzu.